The key to the success of the electric revolution is the creation of safe and efficient energy storage systems. Most of these new energy storage systems may take longer to arrive than others, but there is no question they all have the potential to revolutionize the industry. The use of today's most commonly used energy storage systems in transportation is hampered by several issues, including low energy density, which results in larger, heavier batteries that decrease vehicle performance, comfort, and cost. For instance, the limited range of electric airplanes results from these problems. Also, lithium-ion batteries pose safety concerns, such as the risk of fire due to flammable liquid electrolytes in the event of a car crash. So what makes next-generation batteries so important for the future of electric vehicles? With their potential to offer higher energy density, lighter and more compact designs, and improved safety features, they could be the key to overcoming the current limitations in energy storage systems. Keep watching to learn more about the next-generation batteries poised to hit the market and trigger the widespread adoption of electric vehicles. If you like what you see, don't forget to like this video, click the subscribe button, and hit that bell to get notified of new videos. It really helps us out so we can keep making videos you love. The problems faced by batteries that are used to power electric vehicles today can be solved by developing new energy storage systems, such as fluoride-ion batteries. The operating principle of fluoride-ion batteries is similar to that of lithium-ion batteries, with ions moving between the cathode and anode during charging and discharge. However, negatively charged fluoride ions are used instead of lithium ions. This type of battery now has a prototype developed by researchers from Kyoto University and Toyota, which could be the answer to the shortcomings of lithium-ion batteries. One of the key benefits of this prototype is that it uses a solid, inert electrolyte, making it less prone to fires in the event of battery damage. Compared to lithium-ion batteries, fluoride-ion batteries offer higher fluoride-ion capacities and greater reversibility because the cathode is made of energy-dense copper and the anode is composed of lanthanum fluoride. Researchers have touted the use of fluoride-ion batteries as a solution to making electric vehicles more affordable and providing a minimum range of 620 miles on a single charge. With the potential to offer 3 times the energy density of current batteries, fluoride-ion batteries make the possibility of electric airplanes flying the skies more than possible. At $30 per kilowatt-hour, solid-state fluoride-ion batteries will also be 3 times cheaper than lithium-ion batteries. Despite this, the short lifespan of these batteries is a drawback due to the fast degradation of the electrode materials. Researchers have attempted to resolve this issue by using a cobalt nickel-copper alloy. Another problem is that its solid electrolyte needs a high temperature to operate effectively. While some tests have been successful at room temperature, it may take up to 8 years for commercially viable fluoride-ion batteries to become available. Competition among researchers worldwide to improve lithium-ion batteries with solid-state electrolytes is ongoing. To enhance the safety and energy density that lithium-ion batteries with liquid electrolytes currently offer. Hopefully, fluoride-ion batteries prove that they have a better potential for better energy density. As the world waits for fluoride-ion batteries to become commercially viable, you might be wondering what other advancements could top this. Well, one promising development is structural batteries. Engineers are particularly interested in the potential of structural batteries, which can both support the structure of the vehicle and generate power simultaneously. Tesla has already started employing this technology to make the Model Y lighter. Researchers at the Chalmers University of Technology are pursuing a project that aims to convert the body shell of a vehicle into a battery. They have already developed several prototypes and plan to enhance the technology using carbon fiber as the cathode material rather than aluminum foil. The anode is also made of carbon fiber, and the separator is ultra-thin fiberglass fabric. The current collectors and separators, which compose the inner parts of the battery, have load-bearing capacities in this design. Using carbon fiber, which is lighter than aluminum but equally strong, allows for the creation of a structural battery with rigidity and improved energy storage capacity compared to previous prototypes. The potential for structural batteries to significantly reduce vehicle weight by using the chassis as a battery is significant, despite having lower energy density compared to oxide-based lithium-ion batteries. This new technology permits the creation of thin and flexible structural batteries with limitless applications. The project's lead researcher manufacturer believes that in a few years, consumer products such as smartphones, laptops, and electric bicycles could be half as light and compact as they are today due to advanced structural batteries. But because they also use organic electrolytes, structural batteries are flammable, which is why developing solid-state electrolytes would enhance the commercial viability of structural batteries. Also, it's possible to increase the range of an aerial vehicle by over 50% by replacing the wing panels with structural energy storage elements. This will significantly reduce the weight requirements for electric aviation batteries. A joint venture between Lamborghini and MIT has unveiled a project to transform the Terzo Millennio, a futuristic concept car, into a storage unit for energy. The technology enables monitoring of the car's carbon fiber structure so that when small cracks occur, the charge can flow through the body and start a self-repair process to prevent further damage. The increasing demand for electric vehicles has put a lot of pressure on the lithium-ion battery industry to produce larger amounts of battery cells. Unfortunately, only a few countries shelter lithium reserves. Plus, the companies are forced to delay their EV projects due to supply constraints and the fact that increasing battery-grade lithium production is a tedious process. The world's largest lithium-ion battery manufacturer, CATL, has announced the creation of a sodium-ion battery to be produced in 2023. Unlike lithium, which is primarily concentrated in a few countries, sodium ions, which are used to store the battery's charge, are widely available anywhere in the world. CATL employs a cheap Prussian white material as the cathode instead of the lithium oxides or phosphates used in traditional lithium-ion batteries to accommodate the differences in properties between sodium and lithium. For the anode, the company uses a hard carbon material similar to the carbon-based graphite anode found in lithium-ion batteries, but with the potential for higher theoretical capacity due to a different storage mechanism. In contrast, graphite's theoretical capacity has nearly reached its limit, but adding silicon or silicon oxide may improve it further. CATL has announced the production of a sodium-ion battery for 2023. The battery offers fast charging performance, regaining 80% charge in just 15 minutes at room temperature. It also has a high capacity retention rate, even in temperatures minus 20 degrees Celsius. Like lithium-ion phosphate batteries, sodium-ion batteries can achieve a capacity of 160 watt-hours per kilogram, despite having a lower density than oxide-based lithium-ion batteries. The abundance of sodium ions makes it possible to produce small electric vehicles at a lower cost. The pursuit of improved electrode materials is fueled by the growing attention towards sodium-ion batteries. One would be the newly discovered vanadium pyrophosphate, which has high thermal stability and can serve as both cathode and anode, further enhancing safety and battery life. While all the attention is on sodium-ion batteries, it's essential to remember that portable equipment and electric vehicles have benefited tremendously from lithium-ion batteries. Another way to enhance the energy density of lithium-ion batteries is to incorporate nickel and silicon into the graphite anode. However, these chemical advancements have challenges, such as rapid degradation and safety concerns. Nonetheless, these gradual improvements have paved the way for producing electric vehicles with ranges of 600 miles in 2022. Meanwhile, Tesla's research partner, Dalhousie University, has shifted its focus to mid-range batteries using NMC 532 cells made with graphite without silicon. According to research, NMC 532 cells, composed of nickel at 50%, manganese at 30%, and cobalt at 20%, can maintain over 90% of their original capacity even after 1 million miles of usage, leading the media to dub it the million-mile battery. This format minimizes typical degradation issues, such as particle cracking and surface reactivity. In one of the tests, the researchers observed less cracking and fewer changes in the cathode's crystal structure after charging the battery to only 50% and completely draining the graphite. This led to the development of the 100-year battery called the Sentry battery, which utilizes a lithium bismuth electrolyte and operates at 3.8 volts. offering better energy density than LFP cells used in the Tesla Model 3. With its long life cycle, this technology is crucial for Tesla's long-term strategic vision. It could power the company's future autonomous taxi network and even outlast a human lifespan. Furthermore, by connecting parked cars to the electrical grid, the energy storage capacity of electric vehicles can be utilized for economically advantageous vehicle-to-grid services. This will allow electric vehicle owners to sell surplus energy to companies, adding to the owner's income stream while contributing to a carbon-neutral outcome by balancing energy production and consumption. As the world is slowly accepting carbon neutrality and more money is being invested in research to develop efficient green energy sources, the potential for innovative technologies made possible by next-generation batteries is endless. This was EV News Network with the most anticipated battery technologies that could shake up the world. What do you think is the most ideal among them? Comment your thoughts down below. Until the next video.